What if I were to tell you that nature wants many of us, maybe even you, to fatten very, very easily? That nature makes you insulin resistant on purpose so that you will fatten very easily. I've got a very special guest on with me today. We've been trying for about almost a year now to get this interview set up. I think this is going to be one of the most important discussions that you listen to in 2022, maybe even 2023. I have the great honor of having Dr. Richard Johnson, a medical doctor who's also been very active in research, has numerous published articles, and has just written a new book called Nature Wants Us to Be Fat. Now, if you're a little bit triggered by that title and you want to know more about this, then stick around and just relax and listen to this discussion. I think you're going to, at the end of this, you're going to understand more about human physiology and therefore human nutrition than perhaps you understood before you listened to this discussion. Dr. Johnson.
Hi, how are you?
Man, I'm great. I apologize for the email tag that we've been playing for months. And the
It's
snafus and
great
the
to be on your
mix-ups,
show,
I'm
Ken.
so glad to have you here. For those who don't know about your book or know about the work you do, give us, there it is, Nature Wants Us to Be Fat. And this is not his first book, but this is the book of his that I fully endorse. I think, first, let me just get this out of the way, Dr. Johnson. I'm a great fan of this book. But you've written, what, 3 or 4 now?
Yeah.
And your first books, I was not much of a fan of. But it's amazing to watch the evolution of a learned individual's paradigm as they keep digging and keep looking and keep thinking about things with a fresh brain and looking at things with fresh eyes and going, wait a minute, I don't know if that's exactly right or not. Maybe I took that for granted. Let me re-examine that.
Absolutely.
And so for my followers, I highly recommend Dr. Johnson's last book that he's written, Nature Wants Us to Be Fat. His other books are very interesting, and you'll learn some stuff. But this last book, this is it. Tell us about yourself, Doctor.
Sure. So I'm a clinician. I see patients, and I'm a kidney specialist, but I also, I'm boarded in internal medicine. And so I do clinical work, but I also have had a very active research career. It's been funded by the National Institute of Health. And I've got very interested early on in what drives obesity and diabetes. And as you have written, it's often, when you first start studying something, you begin with a concept that you end up having to modify, and that things aren't always true what we are taught. And so our work focused initially on fructose, and we discovered that fructose really, which is a sugar, it's a carb, and it's present in fruit, but it's also present in table sugar and high fructose corn syrup. And we found that this was the culprit. And so my original books, suggested that maybe all we had to do was to reduce fructose intake, because it really looked like it was the primary driver of the obesity epidemic. And I was on some TV and different podcasts and so forth. And I remember being with Jimmy Low Carb Levita, or whatever, Jimmy Moore. And Jimmy is a big fan of the keto diet and low carb diets, of course. And he pointed out to me, he said, I've tried to just cut back on sugar, but it's not enough to really lose weight. I need to go on a low carb diet or a keto diet. And, according to my work, it was really fructose that was the problem. And so my original book said, hey, you don't really need to cut all carbs. And then, but actually we had a discovery, a scientific discovery, and that was that carbs can be converted to fructose in the body. So you don't actually have to eat sugar to make sugar. You can actually make fructose in your body from starch. And so starchy foods, particularly bread, rice, potatoes, and these foods that you know that are high candidates for causing problems that we know now. And we actually discovered that it wasn't just because they stimulate insulin, because they do, but a big mechanism was that they get converted to fructose. And we were able to prove that high glycemic carbs, that a lot of the way they cause diabetes and so forth is because they get converted in our body to fructose. So it's still carbs. It's a carb story, but as you pointed out, I originally thought it was just fructose that we eat. I still think it's primarily fructose, but it's not just the fructose we eat. It's the fructose we make. And so this led me to the low carb keto diet. And also, I like intermittent fasting as a way to lose weight too. It's really quite effective. These are my
Absolutely.
two favorite approaches to losing weight. And so here we are on your show.
Go ahead. So, okay, now since you are a nephrologist, which is
Yes,
you are a kidney specialist,
right.
before this video went live, I broke my fast about 3 p.m. today because I also believe intermittent fasting is very powerful, and I ate 1.5 pounds of ribeye and about a pound of frittata that was egg and sausage.
How come you
So that
didn't
was
invite me?
a lot of protein, doctor. Did that do any damage? Will that do any damage to my kidneys since you are a kidney specialist?
Yeah. Well, okay. So it's a story. Okay. I got to tell the story. So, many, many years ago, it was shown that in animals that have kidney disease, that if you put them on a very high protein diet, that it could accelerate the kidney disease. And this led to studies in which low protein diets were recommended for patients with kidney disease. The results of the low protein diets in humans is really mixed. And it isn't so clear. What's become more clear is that, like you don't need to really protein restrict patients with kidney disease. And in fact, you don't want to cause malnutrition. There's still this idea that, there's some evidence that at very high protein intake in people with kidney disease can be an issue, especially if you have like stage 4 kidney disease or stage 5 kidney disease. Our work suggests that the mechanism is actually linked with uric acid, and that uric acid, when it gets really high, can promote kidney disease. And so it is true that really high meat diets may raise uric acid and increase the risk for gout. And if you have kidney disease, it's possible. But having said all that, the paleo diet, the carnivore diet, the keto diets, these are very effective ways to lose weight. They're very effective ways to reduce your risk for obesity and diabetes. And so there's a lot of benefits. And in general, I'm a high protein diet fan. Okay. But if you have chronic kidney disease stage 4 or stage 5, I'm not going to put you on a high protein diet. If you have that, that's a very small percentage of the population, maybe 2%.
So there you
So,
have it, straight from the mouth of a kidney specialist,
right.
nephrologist. I'm not destroying my kidneys by eating ribeye
No.
and scrambled egg frittata. Thank you. Now you did bring up uric acid, and you talk about that quite a bit in the book, and I find that fascinating. You as a practicing physician, you know that having an elevated uric acid is not necessary or sufficient to cause gout. But many, many people don't know that. I've seen many patients with very high uric acids who've never had gout. And I've
Right.
seen people with normal uric acid who have repetitive severe bouts of gout. And
It's
so the average doctor, if your uric acid is high, they'll diagnose you based on that with gout and start you on allopurinol. Now, I've
yeah.
seen
So
this hundreds of times, and it's ridiculous. It's not the patient's fault; it's the doctor's fault. But so about 15 million years ago, our ancestors stopped being able to make something called uricase, and this was before we separated from our least distant relative, right? The chimpanzee about 6.5 million years ago. This
right.
was long before that we stopped being able to make uricase, which breaks down uric acid. Why do you think that it was a genetic defect? But as you and I both know, very, very often nature will use a genetic defect and be like, oh no, this actually works better. Let's go that route. Can you talk about that?
Yeah, so nature is incredibly smart. And in fact, I do a lot of studies looking at nature. You can learn from nature because these animals out in the wild have learned how to survive in some of them in incredible situations. I mean, like these animals in the desert. There are all these. Some animals we call them extremophiles because they've learned how to live in the Arctic and they've learned how to live in areas with low oxygen. And I mean, it's amazing. And so there's a whole field called biomimicry where people try to figure out how an animal survives and then try to adapt that to see if you can make new treatments that could help us. And humans, many, many millions of years ago, our ancestors did go through a period of climate change in the mid Miocene. It was called the Miocene disruption, and one third of all species became extinct during that time. And it was actually not global warming; it was global cooling. And at that time, animals were our ancestors were living both in Africa and in Europe, believe it or not. And in Europe it was even colder than in Africa, and there were periods where there wasn't food, especially in the cooler months. Our ancestors at that time were eating fruit. It was even before carnivore. These were like primates that were living in trees and living primarily on fruit. And what happened is they started to starve, and they were living on fructose as their primary nutrient. And there wasn't enough to keep their fat stores going, and they became emaciated and started to die. This mutation increased uric acid levels, and it turns out the way fructose drives obesity involves generating uric acid, which then activates on the works on the energy factories to reduce energy, and then that triggers weight gain and hunger and all these things. And so we actually had the mutation at a time that the mutation was provided a survival advantage because it allowed these ancestral animals to us to survive even with small amounts of fruit. So it was a great benefit at that time. It prevented starvation, but what it did is it really amplified how we can make fat from sugar, from fructose. And so, the mutation didn't make animals fat; it just protected us from starvation. And so it was a good thing. But then what happened was we discovered sugarcane back around 500 BC down in India on the Ganges River Valley. People found this sugar cane and found that they could extract liquid sugar from it, and then eventually powdered and crystalline sugar. And sugar intake started going up. And before we knew it, in 1700, we were eating 4 pounds of sugar a year. The average person was eating 4 pounds a year. It was expensive, and so very few people could afford it. The rich could eat it, and the rich were the ones that were getting fat and diabetic. But then when sugar cane plantations started, and people started growing lots of sugar cane, and then suddenly sugar became less expensive. And around 1900, suddenly people could afford it. The average person could afford it, and the intake went up to as much as 150 pounds a year per person by 1970. And it's gone down the last decade or so, but it's really very dramatic how much sugar we're eating now. It's like 15% of our diet if you're not on a keto diet.
Yeah.
And so what happened is, now we're eating tons of fructose, and we've learned how to make the fructose go and turn into fat. And so what's happened is carbs are driving the obesity epidemic. They're absolutely driving the obesity epidemic, and they do it through this fructose mechanism and through stimulating insulin. And so the low carb diet is fantastic as a way to reduce the risk. And one of the key things that's really relevant to the keto diet and to and to protein and all this is the following. The way the uric acid works is it actually uh, it stuns the mitochondria, or the things that make ATP, and reduces the ATP, and that activates everything. But uric acid amplifies the production of fructose in the body as well. So what it does is the uric acid stimulates the conversion of glucose to fructose. So uric acid is in general not a good thing, but if you're on a keto diet or low carb diet, there's no glucose to convert. So your uric acid can be high, but it's not really causing so much of a problem. And the other thing is that when you're on a keto diet, you're building up ketones in your blood. And there's one called beta hydroxybutyric acid. And that ketone is actually anti-inflammatory. So it actually blocks the inflammation that uric acid tries to create. So it can kind of dampen the effects of uric acid to cause gout. So when you have a high uric acid, just as you said, not everybody has gout, and usually when you have gout, it's associated with systemic inflammation. And so if you can reduce inflammation, such as with a keto diet, then a high uric acid is less likely to cause a problem. Having said that, there are rare cases of people on keto diets getting gout. It does happen, but it's not very common. And I think it's because the ketones are anti-inflammatory, and because we're not eating carbs, so the uric acid can't really convert the glucose to fructose. So yes, if your uric acid is really high on a keto diet, it might cause a little bit of mitochondrial problems. It's better to have a lower uric acid. It's maybe worthwhile for you to measure it. If it's like 9 or 10, that's pretty high, and you might want to talk to a doctor about it. Um, but anyway, it looks like for the majority of people on a keto diet, you don't have to really worry about a high uric acid, especially if it's in the 6-7 range. That kind of goes with being on a keto diet. It lasts for the first month, and then it tends to go down in people if you stay on the keto diet. So,
Yeah, I've seen a few people as they're converting to keto, they'll have a gout flare up. But then
yep.
after they're fully keto adapted, they've been doing it for months, they just don't have gout flare ups
Yeah,
anymore.
that's really cool.
Yeah.
That
Now,
is a very important observation, by the way. I wrote a paper just like what you're talking about, that, you can have gout attacks even with normal uric acids, and you can have a very high uric acid and have no gout attacks. And what I've linked that to is if you have evidence of inflammation. And there's a test you probably have talked about it at times, called the C-reactive protein, or some people call it the highly sensitive C-reactive protein, or CRP. And
yes.
this is a good marker of inflammation. And if it's high, like if it's over 3, it increases your risk for heart disease and heart attacks and gout. It increases your risk for gout. So, if you can get that measured, I recommend it. And keto diets tend to lower CRP levels to the normal range. So
Absolutely.
I think that if you have a high uric acid, my next reflex is to say, hey, get a CRP. If it's high, you may be at risk for gout. And if it's not, you're probably not. But if it's really high, my work makes me worried about it. But but it's not that common to be really high.
Yes. A while back on Twitter, I tweeted the following: nothing makes sense in human nutrition except in the light of evolution. And I'm sure you know that's
Yes.
kind of a paraphrase of Dobzhansky and his famous quote about biology. And I got a lot of flack about that. And I saw DeBarrio's comment here. Sorry, I believe in the creator. And I have to tell you that Dobzhansky was a devout evolutionist, but he also believed in a creator. I also believe in a creator.
Me
These
too.
things, two things, are not mutually exclusive. You can have a firm belief in a creator, but you can also recognize the common sense and the logic and the inevitability of the theory of evolution.
Yeah. I mean, there's no, I agree with you. I go to church and I'm a believer as well, but I also believe in science and I think that evolution does exist. Animals over time, there's just so much evidence for it. And so I'm an evolutionist, but having said that, I still believe in God.
Absolutely. Um, you talk about in one of your videos, and I think you talk about it in the book as well, the research of James Neal. And that this
Yeah.
kind of brings us back to the title of this live. Nature wants you to be fat, and so, or to want some of us to fatten easily. And it kind of depends on your DNA a little bit. But he came up with something called the thrifty gene hypothesis, and
Yeah.
you kind of already covered that a little bit. But I want you to go into more detail and help people understand that being insulin resistant, that's not really pathology.
Right.
That's
Right.
not pathology. That's
Yeah.
physiology. It's normal. And so I for one, I used to weigh 297 pounds, and I'm 6'3", so I like to think I carried it well, but in reality, I had Dunlap. You know what that is, and so I fatten very easily. Now in modern society, with the McWindy Kings on every corner, that's uniformly a bad thing. But 50,000 years ago, I would have been the guy that could eat 2 acorns and half a rat's tail, and I would not have starved to death. So,
Right.
talk about that thrifty gene hypothesis and how that helps us understand that insulin resistance is not pathology. You're not broken.
Right. So first, I'll just mention that our work on fructose identified it as activating a whole slew of things. It wasn't just to increase hunger and food intake. So what we found was that fructose, when it's metabolized, is distinct from all other nutrients, and it activates a switch. I call it a survival switch because it's animals actually use this switch to things like prepare for hibernation, or to prepare for long distance migration. And what they do is they metabolize fructose or they make it, and then they use that to activate this switch to help them survive when there's no food around. And the switch includes behavioral changes. So you get hungry and you start searching for food. So you're like a scout. It's actually, initially it's a good thing. You're able to go out and look, and you it's associated with a little bit of bravery and exploratory behavior, and you can't deliberate on things so quickly or so long because you got to keep moving. So it increases activity. And so it activates that, but at the same time, it tries to lower the overall energy metabolism so you conserve energy. So when you're resting, you're really lowering your metabolism, and it makes you eat more than you normally do because it causes a thing called leptin resistance, so that you don't respond to leptin, which is the hormone that says, "Hey, I'm full." And then it causes insulin resistance, which is actually a survival tool. And the reason is insulin moves glucose into the muscle, and then the muscle uses it for energy, and it moves glucose into other tissues as well, but it doesn't move glucose into all tissues. So the brain can use glucose even without insulin. So when you create insulin resistance, you reduce the amount of glucose that the muscle uses, so there's more glucose left over for the brain. in a situation where there's very little food around, insulin resistance is really helpful because you want to preserve the glucose for the brain over the muscle, because it's the brain that tells you what you're going to do or how you're going to avoid being eaten by a predator. All those things. It's the brain trumps. So the brain gets the the brunt of the glucose when you're insulin resistant. So it actually helps. And so this whole thing of storing fat, becoming insulin resistant, we call that the metabolic syndrome, and a lot of people think that's bad, but actually if you're an animal, that's part of what fat storage is all about. When you start preparing for winter, and when you start preparing for the days when there's no food, you want to become insulin resistant. You want to store fat. You want to learn how to forage for food better. And bears in the fall, they'll start eating huge amounts of fruit, which contains fructose, to
And they
activate
eat
the
that
switch.
fruit, doctor. I'm sorry to interrupt, but the bears, they absolutely do this. And they eat all this extra fruit in the late summer, early fall
Yes,
to stay
absolutely.
slim, to stay skinny, right?
Yeah. So what happens is in the summer they maintain a normal weight, but in the fall they'll eat tons of fruit, not just a little bit of fruit. Fruit is normally very healthy. Fruit does not cause obesity in the normal person, because we're only eating, we're not eating 10,000 grapes. But when a bear eats 10,000 grapes in 24 hours, and they've actually counted it in the scat. That's a bad job to have, by the way. Um, anyway, or a miserable job to have. But anyway, when they eat that much fructose, they activate the switch. Now we're not activating the switch when we eat natural fruits. I mean, maybe when we drink fruit juice and we put all kinds of fruit in there, it's not good. Then we can activate the switch. But one or two fruits not going to do it for you. But eating a lot of fruit, like if you eat like bowls of grapes in front of the TV, you're probably activating the switch. So you don't want to eat a lot of fruit. But anyway, bottom line is you activate this switch, and it's there to help you survive. So the thrifty gene hypothesis that Jim Neal came up with was to say, hey, look, in a period of time when there's no food around, maybe we acquired genes that allowed us to store fat better. And then it helped us in those days. So it was a survival thing that happened. And then when food became plentiful, uh, it's causing obesity. In our case, this uricase mutation that occurred 15 million years ago increased the uric acid and made fructose easier to store fat from fructose. So it wasn't all foods, but it was like fructose. And then what happened was, in today's society where there's tons of sugar, it's actually having a role. And the low carb diet, or the keto diet, actually removes the fructose from the diet, as well as high glycemic carbs that can be converted to fructose. The only way you can make fructose is from glucose. So a low carb diet really is very effective at blocking this pathway.
And tell us, don't keep us in suspense, doctor. Tell us what happens to the bears when they go on this fruit and berry eating binge.
Yeah. So what happens is it activates the switch where they get hungry. So that allows, and normally an animal will eat just as much as it needs, and they'll keep like 10% fat stores. And if an animal eats too much one day, it'll eat less the next. I mean, it regulates it. But if you eat a ton of fructose, you lose that ability to regulate your weight, and you're hungry all the time. And so what happens is the fruit the fruit doesn't cause the weight gain. It's all the other things they're eating, but the fruit triggers them to be hungry, and they keep eating and eating and eating, and they will gain 8 to 10 pounds a day. Some of them even more. And there's a big contest. I don't know if you saw it on the web, but every fall there's a photo contest to take a picture of the fattest bear, and they get really fat, and then they hibernate. And when they hibernate, they'll quit eating, and then they live off the fat. and they're insulin resistant. They have all the features of metabolic syndrome, but it's normal for them, right? This is normal because they're using this as a way to survive. But we're not hibernating, or at least you know, we keep eating,
Right.
and so we're cutting out a key part. And intermittent fasting sort of like giving us the opportunity to fast, which is what hibernation effectively does. And so intermittent fasting is really playing into nature. So that we're not eating all the time. Most animals aren't eating all the time in nature, and that can help. So anyway, so that's the thrifty gene. Now, interestingly, this is sort of a fun story. Um, we identified alcoholism as coming out of a thrifty gene as well. So I don't know if you want to hear that story. Uh, it's sort of interesting. It turns out that humans could not metabolize alcohol originally. It was too toxic,
Yep.
and we had to develop an enzyme, alcohol dehydrogenase,
Yep. And
to
some people still can't. They don't.
yeah,
They don't have
exactly.
enough. That's
Yeah,
right.
it's not, they don't. Yeah, and especially in Japan and the Asian countries, there are people who have problems with metabolizing alcohol. But most people can metabolize alcohol pretty well, and it was related to a mutation that occurred 10 million years ago, so later. Um, and it was a mutation, we think, the evidence is that what happened was it was during another period where there wasn't a lot of food around. And these animals were living in East Africa at the time. And fruit that fell off the tree could start to ferment. And so at that point, when it's fermenting, it's making alcohol, but it's also still got sugar in it. And but they couldn't eat it because the alcohol was toxic. So they actually developed an enzyme or mutated an enzyme so that they could break down alcohol. And then they could eat the rotting fruit that had alcohol in it and also had fructose in it. And then what happened is we discovered alcohol. And so alcohol really goes back there. There's a theory called the drunken monkey theory, which but basically there's evolutionary science that suggests that that alcohol, our ability to metabolize alcohol, is also a thrifty gene. It helped us survive, but now it gives us the advantage to actually enjoy having alcohol. So now we can drink it for all its good and bad.
Yes, absolutely. And I absolutely love. I've fallen in love with anthropology and
Yeah, me too.
paleoanthropology,
I love
and I think that that's very telling. That you also are very well versed because nothing in human nutrition and human physiology makes sense unless you
it.
understand where we came from as a species, why we came from there, how that happened, what genetic defects that at the time seemed like an error, but turned out
Yeah,
to give us basically access to more nutrition
yeah,
and help us to hold extra fat so that we didn't starve to death during the winter. I love that you're so aware of the just the invaluable knowledge
yeah.
in
You can learn
paleoanthropology.
from nature, like the hummingbird. The hummingbird lives off nectar, and nectar is basically sugar water. And this guy has the best metabolism of all birds. I mean, it's like unbelievable. Its heartbeat is super fast. Its wings flutter at some ungodly rate. And yet, it just by drinking sugar water all day, it gets fat during the day. It becomes diabetic in one day, and it gets the fattest liver of any bird. They call it the pearly white liver of the hummingbird. And by the end of the day, even though its metabolism is incredible, it will actually, have blood sugars of 500. And then, during the night, it burns off the glucose, it burns off the fat. And if it even burns too much, it will have to go into torpor where it drops its metabolism. but by in the morning it's ready to go, and it goes out and gets the sugar and does the whole thing all over again. So, when I saw that sugar could take an animal with such metabolism and create diabetes and obesity in 24 hours and fatty liver, it just shows you how powerful sugar water is.
Yep.
And so, um, you can learn from animals, and you can learn from evolutionary biology, and I think that it's not used enough in the field of science. There's too many studies looking at genetic alterations in mice and this and that, and they're all useful. They're very good, but we can learn a lot from nature itself.
Oh, I totally agree. Let's go back. Let's talk about some more archaeology and anthropology. You
Yeah,
mentioned earlier that humans basically discovered sugarcane about 2,500 years ago. That's
yeah,
about how long we've had access to concentrated sugar. And it
yep,
was also right at that same time that Shushruta wrote a
yes,
work called the Samhita, and he basically described diabetes
yes,
as honey urine, and
yes.
he said that it uniformly comes from the upper classes who have access to lots of rice, lots of cereals, and lots of sugar water.
Yes, absolutely. It's a really kind of cool story. I'll tell you how I came upon that. And it's I had read about this, and I knew that Schroeder was the first doctor to describe obesity, diabetes, and heart disease. And he was the doctor in the Ganges River Valley. And he wrote this book in Sanskrit. And I love Google. I don't know if you like Google, but I just love Google. You can Google almost anything, and you can pull up these old books. And so I found an English translation
Ooh,
of this book from 1910. Someone had translated this like 1,200 page book. Okay, so I downloaded on Google Scholar. It's free. I look at it, and then there's a search function where I could search for words. So I took all the old words for sugar. Farinaceous is one,
right,
treacle, all
right.
these like words that we never use, but I started just going through it, and I pulled up all these sections where he talked about sugary foods, and he absolutely linked sugar with diabetes, obesity, heart disease. He did it, and here it is. This doctor out in the countryside in the Ganges, 500 BC. Not only does he figure out what diabetes is, but then he figures out what's causing it. I mean, he was so far ahead of us. There was also there were these doctors. There was this doctor named Stephen Blankart, and he was in Amsterdam in the 1500s, and sugar was just being brought in from the Dutch East Indies, like Jakarta and Java, I should say. And so the sugar was being brought into Amsterdam, and it was a time when the plague had been around. There were all these people who'd been starving, and he started noticing that suddenly people around him were getting fat. And he linked it. He said sugar was the cause not just of obesity and gout, but of bad teeth and cavities. And this was like 1570, again, hundreds of years before everybody else. So although the medical field, as you say, has taught so many things incorrectly to us, if you look hard enough, there was always someone who was pretty bright way back
Absolutely.
when,
Yep.
you know.
And let me ask you about that in modern times. In our current time, it's very common to hear doctors and dietitians, and usually it's plant based doctors and dietitians, say things like too much animal fat can cause diabetes, or too much saturated fat in your diet can cause diabetes. I don't even know what question to ask you about those comments, but what would you care to say to a healthcare provider who
Well,
has a fiduciary relationship to their patients, saying things like, if you eat too much red meat, you will develop diabetes?
so I do have a little story about this, and I think it's going to be quite consistent with what you are teaching. And that is the following that so the first thing is that what seems to be the trigger for everything is carbs, okay, and especially fructose. That is what activates the switch. Now once you've activated the switch, then it makes you hungry, and then foods like high fat foods have a lot more calories. So fat actually can drive obesity in the regular population because it's a two-hit system. First, you got to be leptin resistant, which is really driven by fructose and carbs. And then once you're leptin resistance, high fat diet just drives everything. It just drives weight gain. So if you're an energy balance guy who's like counting calories, it looks like it's calories. But if you do the trick of putting people on a low carb diet, then what happens is they become leptin sensitive. And now high fat diets don't really cause obesity. So, like if you're on a low carb diet, you can eat lots of fat without a problem. And the same thing turns out to be true for meats, red meats, and white meats, and lots of different meats. They when you're a lot of the way they work to cause, if they do cause obesity and diabetes, is through the uric acid, which then activates the conversion of glucose to fructose. But again, if you're on a low carb diet, you're not going to have that disadvantage. And so, maybe super high uric acids could cause a problem, but, but basically, um, meats in someone who's on a keto diet are not going to be a problem. Now, if you're eating a lot of processed red meats, and it's really the processed red meats that have the most highest in raising uric acid, and you're leptin resistant because you're eating a lot of sugar, you might actually get a combination effect. Okay, so you could epidemiologically link it with diabetes, for example. And there are cases, but it's not like red meats cause diabetes. It's like red meats plus sugar. Do you see what I'm saying? I don't
I
know if
do.
I'm explaining
Absolutely.
it well enough, but
Yeah. No,
but but
that makes
but
sense.
yeah. So the keto diet is in general a great diet.
Oh, I totally agree. I totally agree. And I want again to just remind everyone you are a practicing kidney specialist
Right.
who just said that the keto diet is a great diet. We have him
Yes.
on video saying that. He can't retract that
Yes.
later.
There's
And
even
he
some evidence that it might help diabetic kidney disease.
Oh, 100%. And I don't know if you really encourage a diet of any kind in your practice, but I have made a couple of videos about chronic kidney disease. I'm working on the research
Yeah.
for a video about polycystic kidney disease,
Yeah.
and they are all intimately linked to hyperglycemia and hyperinsulinemia, something I'd
Yes.
like to talk in a minute
Yeah.
about as because I think it's distinct from insulin
Yeah.
resistance.
So
But
if I see patients with chronic kidney disease, and you can look at all the notes, and and really an expert in this, I make a major point of trying to tell them to reduce sugar. Sugar intake is associated with chronic kidney disease.
yes,
Okay. I can accelerate kidney disease in animals by feeding them sugar. I have. Sugar can drive kidney disease. Okay. And not only that, high glycemic carbs drive the metabolic syndrome, and metabolic syndrome drives kidney disease.
absolutely.
So you do not want to be on high glycemic carbs and a lot of sugar if you have kidney disease. It's more important to restrict that than it is to restrict protein. And you don't want to restrict protein, not too much. If you're on a very high protein diet and you have bad kidney disease, I will tell you to reduce your protein a little. Okay.
Hey,
Because
John,
if you have chronic kidney disease stage 4 and 5, I will. But it's the sugar and the carbs are worse. Okay. They're worse than the protein.
absolutely. John says, but what is processed meat? My answer to that would be meat that contains added vegetable seed oils, added sugar of some form. Sometimes
Yeah.
it's maltodextrin, sometimes it's sugar, sometimes it's honey. But I don't think that
Yeah.
processed meat, if the ingredients are clean, is a driver of any disease. But I'm going to let Dr. Johnson take that and run
No,
with
I
it.
don't know the answer to that. So I don't know the answer to that.
Gotcha,
So
gotcha.
I'm not gonna go there. But I will tell you another trick that I use, and I totally think this is a great move, is to stay well hydrated. And it's underrated, but drinking water can actually have a beneficial effect not only in kidney disease but for everybody. It can reduce the risk for obesity. They used to call it a myth. I was told it was a myth that hydration was needed because I was said, hey, you're a kidney doc. You know the kidneys can hold on to water for you if you get dehydrated. You don't need to drink extra water. But actually, our research found that being well hydrated can actually slow the progression of kidney disease, can slow the development of obesity. And it's working by suppressing a hormone called vasopressin. And vasopressin turns out to have opposite effects of leptin. So whereas leptin is to make you feel full, vasopressin actually drives hunger and weight gain and seems to be involved in obesity. And most people who are overweight are dehydrated. Most people who are overweight have high vasopressin levels if we measure it. So it turns out that this is another incredible way to help block obesity. Drink 8 cups of water a day. Just do that. And if you have, a special condition like heart disease, or if you're a marathon runner, you're supposed to just drink to thirst. And if you're, about to have surgery, don't drink a lot of water right after surgery because you can hold on to it. So there are these situations where you don't want to drink a lot of water, but for the vast majority of us, drinking 8 cups of water a day is a good thing. And I recommend drinking a cup with each meal, a cup between meals. And don't drink right before you go to bed, because if you get up in the middle of the night, I told you, don't drink right before you go to bed because
That's
you're
right.
going to wake
It's
up.
your fault if you do that. That's right.
It's your
Now,
fault.
speaking of water, I want to talk about a little bit different kind of water, and that's metabolic water. And so a lot of people don't they think we actually burn fats,
Right.
right? When we're losing weight. We don't actually do that. We metabolize it and we make carbon dioxide, which we breathe out. And we also make something called metabolic water. And
Yeah.
many other animals do this. It's
Yeah.
not talked about nearly as much as it should be. Human beings are capable of this. We do this
Yep.
all the time, especially when we're in ketosis, in fat burning mode. You're making your own water.
That's right.
Tell us about this in humans and other animals.
Yeah. So this was, again, this came out of our studies, where we got interested in nature. And you probably know that the fattest animal in the world is the whale. They have huge amounts of fat. And people think that the fat is primarily to provide insulation. And a lot of it is, because when they dive, it can be very cold. And so the insulation helps them. But there's another reason they have fat, and that is that whales, for the most part, do not drink salt water. They do not drink seawater. It's too salty for them. So what they do is they try to get the water from the food they eat, like the little whatever they eat, whether it's a fish or whatever. They'll try to get the water out of that, and they do get about half of the water that they need, and some of them are known to take ice, for example. But it turns out that they use their fat to produce water, because when you burn fat, doesn't contain water, but when you burn fat, you produce carbon dioxide and water. So it's a great source of water. And it turns out that in the desert, animals also use fat to help them when there's no water around. And the hump on the camel's back is fat. And I used to think it was water when I was a little kid. Thought it was like a canteen, but
Right.
it's not. But it's sort of like a canteen, because the fat can be converted to water when they need it. And when the hump's flappy like that, it's because they've the fat's been burned. And one of the main reasons is to provide water. And some desert animals, they'll put the fat in their tail, so you'll like the fat-tailed,
Yes.
jerboa and things like that, these little mice that they have these big fat tails. And the reason is they don't want the fat on their body, just like the camel doesn't, because it will insulate them and raise their body temperature. But if you can put it like on a hump or in your tail, you can get away with it. So when we were looking at this, we realized that mild dehydration might actually be a mechanism for stimulating fat production. It has to be very mild, and they have to have carbs around because, so like there's this rat called the fat sand rat, and he lives in Egypt. He lives in the marshes, or she does, and they eat these reeds that are salty, but and that actually makes them a little more dehydrated. And then when they get dehydrated, they can actually convert the carbs in the grasses, into fructose and things, and so they can make fat. And they try to use the fat they have as a water source. And when you bring them out of the desert, they become humongous because they know how to make fructose from and basically you can make them very fat very quickly. So they've kind of learned how. Again, it was sort of like an evolutionary thing. They learned how to maximize survival in the desert, but then when you put them in a place where you give them regular chow, now they get really fat and diabetic very quickly. So anyway, that's how we figured out this hormone. Vasopressin turned out to be important in causing obesity because it's the hormone that gets activated with dehydration. And we found that sugar stimulates vasopressin, and that when the sugar stimulates the vasopressin actually helps make fat. And so mild dehydration can stimulate fat production. If you're really dehydrated, you start burning the fat. So there's this turning point where if you get too dehydrated, it's no longer wants to make fat, it wants to burn fat.
So let's talk about medical education, doctor, because obviously you and I both know things, believe things, and say things that the average doctor is clueless about. And maybe we're just wrong about everything. That is possible, right?
Right.
But do you think that medical education, how much nutrition education should a medical student get? Also, should a medical student either have to have prerequisites of anthropology, paleoanthropology, or should that be included in the medical school curriculum?
Well, I think that there's so much that could be done to improve medical education. And one thing is exactly that would be to emphasize the importance of evolutionary biology and biomimicry, or the study of nature. I think that people need to know that science is what we call a moving field. And what I mean by that is, there's a certain, like 50 years ago, people are studying, what causes diabetes, and they get this information and they make an interpretation, right? It's an interpretation based on what they know. And then over time, what happens is we get more and more information, and we begin to realize that original hypothesis was wrong. And then we have to readjust the hypothesis. The whole concept that low fat diets was the way to go was based upon, some early studies. And, there was other evidence pointing elsewhere, but, people then start believing it, and then they just remember they remember the title of the paper, and they don't remember the data in the paper. And when finally you realize that everyone's teaching the wrong thing, you go back and then you go, oh my God, the actual data was there originally. It's just,
Yeah.
it was an interpretation problem. So, I think that science is a moving field. It's not that people were intentionally teaching the wrong thing, but rather that as we get more information and more knowledge, we have to learn to go back and and look at what happened and figure out why we went wrong, and then come up with a new best interpretation we can. So that's sort of how I look at it. You know what I do when I have a medical student and they want to study something? I ask them to go to the PubMed, which is lists all the papers, and I tell them to put up diabetes or whatever, and to go to the oldest paper first, and then go like decade by decade to see how people were thinking about what was going on back then, and how different theories came into place. And then how he got stuck there, and then because it really helps you get insights into how this worked, and then with the insights of today, you can go back and go, oh my God, we have to change what we're thinking, and redo this a different way.
Absolutely. I totally agree. Dr. Johnson, what a pleasure. I've got Dr. Johnson's newest book, Nature Wants Us to Be Fat, linked in the show notes. After this video is over, I'm going to put all his other links in there as well, so you guys can track him down and find him. He's not nearly as active on Twitter as he needs to be. We need him in the
I
Twitter
know I
fight.
need to get active.
You need to get on Twitter, Doctor.
Yeah.
Tell us any closing thoughts, any words of wisdom, and also where people can find you, where you're most active.
Yeah, so I have a website, drrichardjohnson.com, and I do put up all my stuff there, podcasts and so forth. I try to get them on. My book is available pretty much everywhere, and I do have an Instagram that I use fairly frequently, and I'm just beginning to use Twitter. And Ken, you're the king of Twitter, and I need to learn from you.
I'll
And
teach you, Doctor.
I'll
I'll
try to
retweet
tag you, and then maybe you can bring some of my stuff into your audience. But I quite admire your abilities to reach out. And thank you again for inviting me to your program. And I wish you success and everything. And I look forward. Maybe we can have another conversation.
Well, Samir says he could watch this for another hour, so I think that's a hint that we should do this again sometime in the near future.
Okay. Well, thank you very much.
All right, Doctor. Thank you very much. Have a good day. Thanks, guys, for joining us.
Yeah, thank you.